All right, class, this is Mr. Eggleston, and this is your quiz 7.5 through 7.7 review. I've decided to give it to you before Easter break because we're at the end. And so it's either wait till after we get back and then you guys will have forgotten everything, or just kind of give it to you next class period, our last class period before the break. So here it is. Always the question is, as my students are talking and making me very angry, is there are 9 questions on this quiz. All right, 9 questions. We start with multiplying polynomials. Multiplying polynomials should be easy for you kids because you just make a box. Now notice, this box is going to be bigger than what we've been doing because these are trinomials being multiplied. But it's the same idea. You take one of the factors, 5x squared minus 5x minus 4. I wish I should separate that further apart so you have more. I have more space. There we go. All right, and then down the side is x squared minus 4x minus 1. So instead of 3 columns and 2 rows, we have 3 columns and 3 rows. All right? And so you just fill in the box. So 5x squared times x squared is 5x to the 4th. Negative 5x times x squared is negative 5x cubed. Negative 4 times x squared is negative 4x squared. Then we go negative 4x times 5x squared, and that's negative 20x cubed. Negative 4x times negative 5x is 20x squared. And negative 4x times negative 4 is 16x. Then last row here is negative 1 times 5x is squared. Negative 5, sorry, let me say that again. Negative 1 times 5x squared is negative 5x squared. Negative 1 times negative 5x is positive 5x. And negative 1 times negative 4 is 4. What's nice about the box, it lines everything up. You just add like terms. So notice there's nothing that can add to 5x to the 4th. So that term just stays here. But then you start adding down the back diagonals. Okay, like this. So negative 5x cubed plus a negative 20x cubed is negative 25x cubed. Negative 4x squared plus 20x squared is 16x squared. Minus 5x squared is negative 11x squared. And then 16x plus 5x is 21x. And then you have the plus 4. That's how easy it can get to multiply polynomials. So we multiplied 2 trinomials together, and we had to use a 3-column and 3-row box to do that. But it's pretty straightforward once you do that. On question 3, this is a polynomial in factored form, and they're asking you to find all roots, imaginary and real. Okay? So you just said each factor equal to 0 and solve. The x minus 1 equals 0 be x equals 1. X plus 1 equal to 0 will equal x equals negative 1. The only one that's a little bit odd is this 5x squared plus 1 equal to 0. Solving that, subtracting 1, you get 5x squared equals a negative 1. Divide by 5, you get x squared equals negative 1/5. Now you have to take the square root. Get rid of the squared, and that's plus or minus the square root of negative 1/5. Negative means it's imaginary, like Ian's friends. So that's plus or minus I. I'm just saying Ian because he's in my class. They're so good, these kids. So that'll be the square root of 1 over the square root of 5, which is plus or minus I, 1 over the square root of 5. I'm okay with you leaving your answer like this. However, if you go into higher level math, they're going to yell at you if you do because you can't divide by a square root. Square root cannot be on the bottom because square root of 5 is irrational, and so you'd be dividing by a really ugly number. So what they want you to do is rationalize it. Is what it's called. It's basically you're going to take. This is how you would divide also radicals. You just multiply top and bottom by the square root of 5. Notice when we do that, this becomes plus or minus 1 times the square root of 5 is square root of 5 over the square root of 25, which happens to be the square root of 5 over 5. And there, what I forgot was the I. So there you go. It's plus or minus. All right, there's 1 0, and there are 2 other zeros here. Okay, so there's 2 real zeros, 2 real roots or x-intercepts, and 2 imaginary. And it's kind of hard to see the I. So let's make sure you make it, it's right there. Notice I put it in front of the radical. All right, now it's question numero dos. Question 3 is I give you a graph. And I tell you the graph of a 5th degree polynomial is shown. The graph passes through 2, 4, so I give you this point right there, and I tell you it's 2, 4. Shown on the graph. Note the graph is cut off at y equals negative 4. It's just because this graph would go way down here to negative, I think it was negative 40 before it turned around. And I just didn't want to have to make the grid that big, so I just cut it off. All right, so they say, first of all, is x plus 1 a factor? All the zeros are given here. There's a 0 there, there's a 0 there, and there's a 0 there at 1, 3, and 6. Notice, if the factor is x plus 1, that means it has to have a 0 at x equals negative 1. All the zeros are shown. It doesn't have one. So is x plus 1 a factor? No, it is not. The graph does not have an x-intercept there. Intercept at x equals negative 1. Okay. Is x minus 3 a factor of the polynomial? Well, here's x minus 3 means it has to have an x-intercept at x equals 3. Well, it does. Actually, it's a x-intercept that has a multiplicity of 3. How do I know it's to the third power? Because look how it crosses. It doesn't pass right through. It crosses with a little hitch in its giddy-up, so to speak. So, yes, x equals, or I should say x minus 3 is a factor. Okay? Because the graph crosses the x-axis there. The x-axis there. Okay? Write the equation of the polynomial in factored form. All right? So, well, we can see that f of x would equal a, the stretching factor, times x minus 1. Notice it's a multiplicity of 1 because it passes straight through at x equals 1. But here's where you got to be careful. Also at x minus 3. But now notice how it's a little hitch in the giddy-up. It doesn't pass through. It does pass through, but it doesn't pass straight through. This is to the third power. And then x minus 6. Okay? So at x equals 2, if the graph passes through 2, 4. So we'll use that. 4 equals a. 2 minus 1 is 1. 2 minus 3 is cubed is negative 1 cubed. And then 2 minus 6 right there. So we end up with a times 1 times negative 1 cubed times negative 4. So that turns out to be a positive, and this equals 4. So that's actually a positive 4. So it looks like 4 equals 4a, so a must equal 1. So putting all that together, you have your final factor form of the polynomial. Easy peasy, not too hard. It was a little bit tricky with the little hitch at x equals 3. You had to recognize that to be a cube, not a squared. A squared is a bounce, and to the first power if it passes straight through. I am not asking you to write this in standard form, so don't worry about trying to multiply all these factors together. And that's your answer. Okay? Question number 4 is divide this polynomial by n plus 2. So remember how we do this. I'm just going to do it the way the people who created this curriculum does it, where you do the reverse box. So you got xn cubed here, then you have n plus 2 down here. So what do you have to multiply n by to give you 6n cubed? And you'll say 6n squared. And then that'll give you 12n squared here. So what needs to be up here? Remember, those two have to add to give you 3n squared. So if that's 12n squared, this has to be a negative 9n squared, I believe, because negative 9n squared plus 12n squared does give you 3n squared. So this will be negative 9n, because negative 9n times n gives you negative 9n squared. Down here will be, just multiply 2 times negative 9 is negative 18n squared. All right? So now, what needs to be here is that the sum of, I'm sorry, not n squared, bad Aggie. That was negative 18n. So this sum here has to be equal to negative 26. So what do we add to negative 18? To get to negative 26, that would be negative 8n, or negative 8n. So this will be negative 8 times n, that gives you the negative 8n, and negative 8n plus a negative 18n gives you negative 26, and which works. And then finally, negative 8 times 2 is negative 16. All right? Now, does it divide evenly? Explain. Well, notice, we ended up with a negative 16, but we were supposed to end up with a negative 23. They are not the same. It does not go in evenly. So the remainder is going to be whatever we have to add to negative 16 to get to negative 23. So we're going to have to add a negative 7. So it's a remainder of negative 7. So does it go in evenly? No. The remainder is not 0. It is equal to negative 7. So it doesn't go in evenly. You could actually write out what the quotient is. I mean, the quotient would be 6n squared minus 9n minus 8 plus a negative 7 over n plus 2. And that is the actual quotient of those two polynomials being divided. But they didn't actually ask you for this. They just want to know, does it go in evenly and why? No, it doesn't, because the remainder is, I didn't even write it right, is not equal to 0, ... It is equal to negative 7. That's how you should write it. All right. State of the given binomial is a factor of the given polynomial. Explain. Well, 4 and 5 are exactly the same kind of question. If n minus 4 is a factor, that means that if we divide n minus 4 into this polynomial right there, it should go in evenly, which means a remainder of 0. So let's try that. Let's just go through the painful process of dividing. Sorry, I just lost my train of thought there for a sec. All right, so this is, we'll put n minus 4 down the side. Okay. And then we have our little box here. And then we put the first term in right here, n cubed. So obviously, n times what gives you n to the third? That's n squared. That's n cubed, that works. And this is minus 4n squared. So adding these two together right here has to be negative 7n squared. So that means you have to add negative 3 to negative 4. So you have that. What do you have to multiply n by to give you negative 3n squared? That would be negative 3n. And then negative 3n times negative 4 is a positive 12n. What do you have to add to 12n to give us 16n? That's going to be 4n. 4n times a negative 4 is a negative 16. Okay? Notice, we're supposed to have a negative 19, but we have a negative 16. So this too states that, means that n minus 4 is not a factor because we have a remainder and we have to figure out what do we have to add to negative 16 to get to negative 19 of negative 3. Okay? But that's all you have to do. It's not really that challenging. All right, then there's a lot of dividing. The next one is take that polynomial, x cubed minus 9x squared plus 12x plus 32, and divide it by x minus 4. It's just more of the same. And they want you to write out the result. So it is, we just do the same thing we did on the previous ones. We write x minus 4 down the side. Then we fill in, make our box. And you put the first lead coefficient there. This has to be x squared. This becomes negative 4x squared. Then whatever we do, we have to add to get negative 9x squared. That's what this is. So that's a negative 5x squared, which means we have to multiply x by negative 5x, which gives us a positive 20x down here. All right, whatever we do, we have to add to get negative 12 or positive 12x, so we have to add a negative 8x to that. What do we have to multiply x by to give us negative 8x? And that will be negative 8. And then negative 8 times negative 4 is a positive 32. Notice, as my class will still continue to be quiet, I only have two more questions. Three more. Oh my gosh, this is long. All right. So notice 32 and 32, they match. So so the result is this, the quotient is equal to x squared minus 5x minus 8. And x minus 4 goes in evenly, so there's a remainder of 0. Okay, so that's the answer for that one. On number 7, almost done. We just got 7, 8, 9. Which reminds me of that awesome math joke about why was 6 afraid of 7? Because 7, 8, 9. All right, so the graph of f of x equals 6x cubed minus 7x squared minus 63x minus 20 is shown. Find all, capitalized all zeros of the polynomial, real and imaginary. All right, so the degree of this polynomial is 3. So at most we should have 3 zeros. So notice, we actually have 3 real zeros, so there are no imaginary zeros, there's only real zeros. So we can see that we have one definitive 0. We see at x equals 4 that we have an x-intercept. That means the factor of x minus 4 goes into that polynomial, and we will divide. So that's how we do this. So we're going to divide. Okay. We have x minus 4 down the side there. And then we put the first term here of 6x cubed. What do we have to multiply x by to give you 6x cubed? That will be 6x squared. 6x squared times negative 4 is negative 24x squared. We have to add a number to negative 24x squared to get to negative 7x squared. Oh my gosh, so what to see? It will have to be a positive. And let's see, what's 24 minus 7? Why am I blanking on that? I do not know these things. Let's see, that's 17? Yeah, so it's this has to be 17x squared. What do you multiply x by to give us 17x squared? And you will say 17x. Gotta love it. That gives us 17x squared, and 17 times negative 4 is something, oh my gosh. Okay, that's 4 times 7 is 28, 4, 68. So that's going to be negative 68x. Okay, and then what do we have to add to negative 68x to get to negative 63x would be a positive 5x. So we know that this last one's got to be a plus 5x, or just 5x, I guess. I don't have to put the plus there. And that gives us 5x squared. Or wait, yeah, what do we have to multiply x by to give us 5x? And that's going to be plus 5. And that gives us a negative 20 down here. And please, oh, look at that. Man, Mr. Eggleston, you're awesome. Says no student ever, but that's okay. I like to believe I am. And you see they match. So x minus 4 does go into that polynomial. So we can break that polynomial down to x minus 4 times 6x squared plus 17x plus 5. Now, you're free. It's a quadratic. You could probably factor this, hopefully. That's what I'm going to do. If not, use the quadratic formula, but I believe it's factorable. I'm going to look for products of 6 times 5 is 30. Remember, 6 times 5 is 30 and add up to 17. Well, that's going to be 15 and 2. Okay. So, again, this is a little bit tricky to fully factor this. So remember how we do this. We write the first term of the 6x squared there. We write the last term, 5 there. Then we just put 15x and 2x. And you know, what's common between 6x squared and 2x? That's going to be 2x. Then what do you have to multiply 2x by to give you 6x squared? That's going to be a 3x. And then what do you have to multiply 3x by to give you 15x? That's going to be 5. And then 5 times what gives you 5, and that's going to be plus 1. And 2x times 1, so it all works. So now, I'm just going to continue down here because I'm running out of space. So now we have basically the x minus 4 that we got from the original looking at the graph. And then we also have the two other factors of 2x plus 5 and 2x plus 1. That equals 0. That gives us 3 zeros. You got x equals 4. You got x equals negative 5 halves. And you have x equals negative 1 half. Those are the 3 zeros. Okay. Looking at coming up to the end, this is the last one. Yes. No, it's not. It's the penultimate one because I almost forgot that. Write a polynomial function of least degree with integral coefficients that has the given zeros. The lead coefficient is 1, so that just means you don't have to look for a. So basically, this is pretty straightforward. You want to leave it in factor form, I believe. Yeah. So this is going to be f of x equals x minus 2, x minus 1, x minus 0, x minus 4, and x plus 4. I would argue to put the x minus 0, the x, in front, and then you would have this, because that's how we tend to write it. Would it be wrong if you don't? No, not really. And that's how easy this is. Easy like Sunday morning. So, now, that incorporates all the zeros. And notice there's 1, 2, 3, 4, 5. We got 1, 2, 3, 4, 5 factors. So it's a 5th degree polynomial. All right. Wow. Last one. Pretty easy. Very similar to some of the other problems. I give you this polynomial, cubic, and then I tell you x plus 5 is one of the factors. You want to use that as your hook to find all the other factors. So we just divide x plus 5 into the given polynomial. Okay. So here we go. We put x cubed here. What do you have to multiply x cubed or x by to give you x cubed? And you'll say, I hope, x squared. I'm gonna lower this because I'm gonna be. There we go. All right. So and then x squared times 5 is 5x squared. What do we have to add to 5x squared to give us 7x squared? And that's going to be 2x squared. What do you have to multiply x by to give us 2x squared? Is 2x. Okay. And then that's going to give me 10x. 10, not 16, 10x. And then what do you have to add to 10x to give us 7x? And that'll be a negative 3x. What do you have to multiply x by to give us negative 3x is negative 3. And then negative 3 times 5 is negative 15. And once again, it goes in evenly. All right, so now we got that this polynomial is going to be the x plus 5 that was given times x squared plus 2x minus 3. To factor fully, we're going to have to factor this quadratic right here, which is pretty straightforward. You look for two numbers, multiply to negative 3, add to 2. So that's going to be positive 3 and negative 1. So we can now factor this polynomial as x plus 5, and then it will be x plus 3, x minus 1, and that's the fully factored polynomial. Okay, I gave you the answers, so you can check your work. Notice on 8, they wrote it out. I would argue that on number 8, leave it leave it in factored form. Don't bother trying to multiply it out. They did. Okay, but there you go. I hope this helps. Don't be worried. It's going to be a pretty straightforward quiz. And I'll talk to you later. Bye-bye.